Touch the leg and greetings to all my dear students. Well, as of today, I'll be starting with a new chapter. The name of the new chapter is Python Libraries. So we are completely done with the recent chapter of data structures. So it's time now to move on with the next chapter. So this chapter, unlike the data structures, is relatively simpler and shorter. So without any further delay, let's get started. So I would like to first offer you a brief introduction on this chapter of Python libraries. Let's take an example of a book, be it any book. It could be a storybook, a novel, the reference book. You will see one thing in common. This example is mentioned at the very start of the chapter in the textbook. So I thought, why not, tell you the example. So be it any kinds of books, there is one big common thing, and that is the whole book will always be divided into the chapters. And each chapter has a reason of its own behind them being a chapter or a group, because they have some kind of reasoning or relationship. That's the reason why the whole book is broken down into the various units or the chapters. Otherwise, imagine a book without any chapters, without any units. The book will be so boring to read, and it will also be very difficult to comprehend. So likewise, when it comes to the program of a big nature, when the program is just too big, normally the trend is the program is divided or partitioned into the individual components or individual units. Okay, so the reason is pretty simple. It's easier to handle, it's easier to manage. All right. So likewise, your program could contain the variables, the constants, the statements, the functions, the classes, the objects, even though the class and object is not a part of your curriculum, but it is really very important. So your program could contain various kinds of program components. Just having all of them without any separation, without any categorization as a part of one big program, it's very difficult to handle, it's very difficult to manage. And then needless to mention that it's very difficult to comprehend the program. So that's the reason the program is often divided into individual unit or individual components. Okay, so this is the very meaning of the library. Okay, so the library is the collection of modules which cater to a specific type of application or specific type of requirements. Just like you have chapters in the book. The first chapter is to do with the childhood. Let's say if the book is based on a biography, the chapters are often categorized as, let's say, as an example, the first chapter is on the childhood of this great personality, and then the school life, the college life. So similarly, the module, will actually contain certain components, and these modules are grouped based on the nature of their functionality. So the library will contain the modules. I'll come to the modules a little later. So the library is nothing but the collection of modules, and where you will see one common feature. All of these modules which are packed inside a library have some commonality, some common feature with regard to the application or the requirements. Okay, so in the Python, the programming language, there are many libraries. Okay, the first one is Python Standard Library. So the reason why it is named as standard is these or this particular library comes as a part of the Python distribution. So this library is distributed with the Python softwares. But the rest of the other modules like the Numpy, the SciPy, these are not these static library, which means they come separately. So if you want to implement, or if you want to use those libraries, you need to have them downloaded or installed in isolation, right? So there are many of them. The first one is Python style library. You have the math module. So understandably, this the math module will have the functions with regard to the calculation, and then CMath module, as the name suggests, will have the functions with regard to the calculation of complex numbers. And this module, which we'll be dealing with little later, this module is used to generate pseudo random numbers, which are often used in playing games like the snake and the ladder, throwing the dice, and then as a result of which there should be a random numbers being generated. So that's just a simple example or application of random module. And then in the field of statistical mathematics, again you have many functions which are packed in this module. And then LIV, is again a module which will contain functions with regard to accessing the websites from within the Python program, right? So all these modules in the field of scientific application, SciPy, and then you have the Numpy. So all these are either used in scientific application or the mathematical application, right? So this Numpy, is again a wonderful module which will not only help us to perform calculation on complicated numbers, but it will also help us to deal with the Numpy arrays. I did mention something about arrays. Array is a data structure which contains homogeneous elements, which belong to a similar data type, right? So likewise, there are many modules which are a part of the Python programming language. So these libraries, basically contains a collection of modules. Now the next up is what is meant by module. Module is a file. It's nothing but a Python file in which there are components. There are components like, it could have the doc string, and then the variable, the constant, the classes, the object, the statements, and then you have the function. So module is similar to a Python file, okay, which will cater to a certain type of need. Or in other words, you could define module as, module is a separate unit, a unit in itself, which could form an independent component or part of the program. Okay, you have one big program. Like I said, the whole program could be divided into a library or module. So these two words, library and module, are interchangeable in their usage. Okay, there is no black and white kind of differentiation between the two. They could be used interchangeably. So the whole big program could be divided, or it could be partitioned into a separate unit or individual component. A unit in themselves, logically, they are independent, right? So these are nothing but the modules. Okay, so now why module is so important? There are three important reasons. I've listed the topic here, why modules are so important. The first one is, with the help of module, you'll be able to reduce the complexity of the program to a great length. Okay, like I said, if the storybook doesn't have any chapters, any unit, the whole storybook will be so difficult to comprehend, right? So likewise, with the help of modules, the program's complexity could be reduced, right? That's the first benefit or the reason. The second benefit is it helps us to create well-defined, right? Well-defined and then documented, separately documented, well-defined, and then you have well-documented boundaries. Not just the the individual parts of the programs will be well defined, but there will be a proper boundaries between the individual components or the individual parts of the program, right? So the first one is, it helps us to reduce the program's complexity. But how it's done, with the help of module, the program will be divided into well-defined or well-documented boundaries. All right, and then the third major benefit or the reason is the modules in a program could be reused without having to rewrite. What is meant by this is, let's say I come up with a program in which the program is all about playing a sound or playing audio format. Okay, that's the big program that I've designed. In this big program, I have various components or modules like, I come up with a function, I come up with the first component, which will help me to play the audio format of the radio, let's say. And then the second, the module could be with regard to playing the audio from the CD. Okay, the third one could be from the MP3 player. So I have one big program in which I have modules, separate modules, which could play audios, of different kinds of formats. So this is what I've designed. Let's say my co-programmer wants to come up with something similar, or maybe some other program, but he needs to use just one function of audio play with regard to the radio. Okay, so he need not rewrite the program. All he could do is he could reuse the one which I've used it, right? So he could just import my module onto his program. Okay, so if my program was not divided into modules, my co-programmers or the other people will not be able to use or reuse my module, right? So since I have well-defined, the whole program is divided into, the independent, the separate logical unit in the form of the module, with which that means, the others can import and use just that part which they need to have it as a part of their program. All right. So that's the reason. Okay, why modules are used. Now this is a very important question. So now, in order to understand further, we'll try to come up with a user-defined module. We'll try to come up with our module, and then we'll see how to use or how to implement that module in the program. Right? Now let's say let's come up with the module. The name of the module will be, say, 3 single quotes, and then I'll have the module name as the temperature conversion, right? But first things first, the module should contain the doc string, okay? It should contain the doc string. I'll explain what is doc string. So I'll have something like this: the temp conversion between centigrade and the Fahrenheit, right? So this is the doc string. So the doc string is basically, it's like a comment. It helps us to provide explanation for the program. Or you have this term called documentation. Documentation means you have the manual which comes with the purchase of various electronic and electrical devices regarding how to use it. So it's provided in the documentation. So likewise, these are just like the documentation which will help us to understand the program better. Okay, and then you can use the 3 single quotes and 3 single quotes at the start or at the end. So this is the first documentation, and then I could also have the the functions, the statements or the functions, and then likewise I can have the class and the objects, and then finally you can have the constants. All right. So let's come up with the first function, that is to. Now this function is to convert the temperature into centigrade, right? Just write the centigrade, and then again I'll make use of a dot string, right? So return x converted to centigrade. So this is again, one dot string, right? And then let's come up with now this is not a technical part of the function definition, right? So the body of the function will be, just have this single quote, and then we'll have the return. I need to copy the formula again. Remember, 5 multiplied by x minus 32 divided by, you have 9.0, right? So this 9 divided 9, 5 into, okay, 5 into x minus 32. What's happening? 5 multiplied by x minus 32 divided by 9. So this is the formula to convert the Fahrenheit to the centigrade. Alright? Now let's come up with the second function, and that is def2, and then Fahrenheit. Again, we'll have the x, and then the dot string, the third dot string returns. Okay, and then x, now this time x is converted to the Fahrenheit, right? Okay. So, and then finally, I need the formula to convert the, the centigrade to the Fahrenheit, right? So for this, the formula is 9 multiplied by x divided by 5.0 plus 32, right? I hope I got the formula right, hopefully. Okay. And then, now these are the 3 dot strings, and then I have the statements and the function. You can also have some constant values with regard to the modules. For example, in case of mathematical stuff, there are many constants like light year, the pi value, the radian value, right? So it's important, to have the constant values defined as a part of module, so that you don't have to recall or remember. Or all you could do is just access the constant values through the variables, right? So now let's, for the sake of example, let's say the freezing centigrade value is 0, and then the freezing temperature in Fahrenheit is equal to 32, right? 32.4, right? So this is a very simple example of the module, right? So like I said, the module should contain the dot string. Dot string provides the documentation or the explanation of the program, and then it should have the statements and then the functions. There are 2 functions, 3 dot string, and then you have 2 constant values, right? And then even though the class and the object is not taught to you, it's not a part of your curriculum, just for your understanding's sake, I'll give you a brief explanation. You can also have the class and the object as a part of your module, right? So these are the components of the Python modules. So class is like a blueprint for creating certain kinds of object. Just get a brief idea, that's more than enough. I repeat, class is like a blueprint for creating a certain kinds of object. And then object is one such instance of a class. If I come up with an analogy, human being is an example of a class. Okay? Tenzin is an example of an object. So if I go closer to the programming sense, I come up with a class of rectangle, or I come up with an example of student, okay, in which I have the member, the data members, data like the roll number, the name, the addresses, okay, and then the marks, and then there are 3-4 functions which are used to calculate the percentage, the body mass index, whatever it is, right? So I have one class in which I have the data listed, and then the functions listed. So this is like a blueprint or the class. Now if you want to really have it implemented into your program, let's say a new student, I need to really assign a name, admission number to one particular student. All I do is I create an object from this class for that student. The moment I do it, that object will have all the characteristics from this class. Alright? So with the help of class and object, the programming process will be simplified to an unimaginable length. But since this is not a part of your curriculum, let us not go any further. Okay? So the fact of the matter is, class and the objects are a part of the programming, the Python programming module, right? So the next up is, so I hope you are clear with this. The structure of a Python module, it should contain the docstring first, and then the statements, the function, the class, the object, the variables, and the constants, right? So now, once I am done, I need to save this. Alright, I'll just save it. I'll save it, and then the file name should be, let's say, 10 conversion, right? And then I save it, and then say yes. Alright, so the name of this particular module is 10 conversion. So the name of the file is indeed the name of the module. The file name with which you have come up with the module name is going to be the name of the Python file. So that's what I was telling you. The module is nothing but a Python file. It's a Python file, but with the components like I just mentioned a while back, right? Now the question is, how do I use this? All right? How do I use this module into the program? All right? So what I'll do is, say I would like to use the function of 2 centigrade. Okay, I want to use the function of 2 centigrade, with which I want to convert a temperature value from the Fahrenheit to a centigrade, right? So if I do it directly, it will not work. Let's say I call upon the function centigrade, okay, centigrade. And then let's say I have here 100, right? I want to have this converted to centigrade, or perhaps I'll just have the boiling temperature in the form of Fahrenheit, right? So the value should actually be 100. So 212 is the boiling temperature in Fahrenheit. So when I convert this to the centigrade, I should get the answer as 100. But when I press enter, it doesn't work. The reason is, it says 2 centigrade is not defined. So this module has to be imported into your workspace. Into your current workspace, you need to import the module. Otherwise, you cannot use it, right? So first things first, you have to import the module. The name of the module is 10 conversion. Remember, the name of the file is 10 conversion. That's going to be the name of your module. Now, when I press enter, this module, the whole module has now been imported onto your current workspace. Okay? And then you try to run it, 10 conversion. Okay? How do you use it? As you have to use the dot notation, which separates the name of the module and the name of the function. Okay, so you have to use dot operator or the dot notation, and then it immediately shows up the available components in your module, right? So I'm going to use, if you pick up from here, it's safer. You will not make mistakes with regard to the spelling. So let's say I'll have the 2 centigrade, and then I'll have 212, right? So when I press enter, I'll get the correct answer of 100, which is the boiling temperature in Celsius or in centigrade, right? So when I ran the command prior to importing, it didn't work. The reason is the module has not been imported onto your workspace. So once I import it, I could now use it with a dot notation, which is, which separates the name of the module with that of the name of the function. Alright, so this is a basic way of how to create a module and then how to have it imported onto the workspace or the program. Now let's say I want to print, I want to check out a certain value, or if I want to use it, okay, say if I want to just write the name of the module, that's type conversion, okay, and then followed by the name of the constant, freezing C, and then when you press enter, you will get the answer as 0.0. So likewise, you can also check, the other one, freezing, okay, and then you have the F, you will get the answer as 32, right? So this is how you import the module, as a result of which you could access or you could use these functions and the constant values. Now this is the main thing about module. Let's say the program is very simple, anybody could come up with the logic, but just in case if somebody wants to have temperature conversion as a part of their program, they don't need to rewrite. In fact, they could reuse the one which I have as a part of my program, right? Now let's come up with the next variation. Let's check out the next topic. Okay, I've come up with the example. Now look at this. How do you import the entire module? So if you want to import the entire module, you need to specify the statements like this. Import, and then you mention the module. All the functions, all the components in that particular module will be imported onto your program, okay? But just in case if you want to import just one of them, sometimes the module could be so big that if you import the entire thing, it will unnecessarily lead to the consumption of the memory. But instead, you would like to have just few of them imported onto your program. If that's the case, then you need to use the from module, right? So I'll just close this and then I'll just reopen because I need to get rid of that imported module, right? So ideally, I open this. I'll just get this on top. Okay, now let's say I want to just call upon the 2 Fahrenheit. I don't want to import the rest of the module, right? So for that, you have to have the keyword of from the name of the module, which is temp conversion, and then import, just write the name of the function, which is 2 Fahrenheit, right? And then you have this, if I'm not wrong, I don't think you have to specify this. Okay, press enter, right? Now, what I've done is, I have imported 2 Fahrenheit, not 2 centigrade. So if you try to run that temp conversion .2 centigrade, it will not work. Okay, so if you want to just check it out, let's say temp conversion, and then you have 2 centigrade. I better get the spelling right, and then you have 212. Remember? So when I press enter, it will not work. Alright? Now the thing here is, the moment you import one particular function, you don't need to specify the name of the module. Okay, I repeat, since you are not importing the whole module, you have just imported one function from the module. In which case, when you want to use it, just specify the name of the imported function. Okay, you don't need to specify the name of the module, right? So the point that I'm trying to get is, now say this is the one which I've imported, right? So if you want to use it, just use it like this. Fahrenheit, right? I'm converting to Fahrenheit, right? So if I have 100, okay? So I got the spelling right, and then when I press enter, there you go. So this is, what we mean by qualifying. Qualified means if you specify the name of the module, then you are providing the qualified name for this function. Am I providing the qualified name or the name of the module for this particular function? The answer is no. Why it is not required? The reason is I have not imported the module. Okay, I just imported the function. So which means I can just specify. I do not need to qualify, or I do not need to provide the qualified name for 2 Fahrenheit. Right? Just specify it and then it will work. But the problem is, will it work for centigrade function? Centigrade. Okay, and then you write 212. I've got the spelling right. Centigrade. The moment you press enter, it's not defined. That's because I have not imported the function of centigrade. So if I just sum up, okay, it's pretty simple. If I want to import the entire module, then use the statement like import the name of the module. In our example, import temp conversion. Now say you want to use all the components. When you use all the components, they need to be qualified. Qualified means I need to mention or I need to specify the qualified name or the name of the module. So if I import the entire module, if I want to use all these components, they all need to be qualified, which means I need to specify the components along with the name of the module. Okay. However, if you want to import just 1 or 2 components from the module, you have to use the keyword of from, right? As I've specified here. Where is it? Okay, it's here. From user, right? From this particular module, import this. And then if you want to use 2 Fahrenheit, you just have to specify the name of the component or the name of the function. You don't need to specify the name of the module, right? So I hope you are clear with this. Now let's say, now this is, one good example of how to create a user-defined module. Say you have certain commands like help. Okay, so let's check out. I've not imported the module of the temp conversion. Let's do it. Let's say import, and then the name of the module is temp conversion. All right. Let's say I want to use the command of help. Let's see what happens. Temp conversion, right? So when I press enter, what do we see here is it provides us the help on this particular module, right? Help on module temp conversion, okay? And then the one which I've written up there, all the doc strings will be displayed. So when anybody for that matter reads the doc string, that person will have a clear idea of what this module is all about. So this is the meaning of documentation, right? So whatever I've written over there, doc string will be a part of the help command, right? And then this is, up there. And then come little down, what do we have? The functions, the name of the functions along with the doc strings, which I've mentioned as a part of the functions, right? So if anybody reads it, they'll have a good idea regarding, the nature of all these functions, right? So as and when you go on, they will show not just the function, they will also show the data, and then it will show the address in which the module has been stored. So help command is a very, very useful command, right? Now let's say, now this is, the thing about the user-defined. Now let's try to compare with the user-defined. Let's try to compare the user-defined with the built-in module so that we'll understand better. Now let's say you're familiar with this POW 2 raised to 3. I get the answer as 8. So which means this function should be a part of a module. Okay, it has to be a part of a module. But I've used it without specifying its qualified name. I've not qualified this function. I've not specified the name of the module, which means it wasn't imported using the import followed by the name of the module, or from keyword. So clearly, this for function has been imported using from keyword, right? So when you import a certain function using from keyword, then you don't need to specify the name of the module, right? So the module for this particular function is the math module, M-A-T-H. So math module is a big module in which you will see a lot of functions, mathematical functions, most of them, and then of course some constant values, right? So now let's say I want to use the function of square root, okay? Square root of 4. So when I run this, I get an error. So which means for function has been imported like from math import home. However, this has not been imported, right? So if you want to use it, either you could import the entire math module, okay? Import the entire math module and then use the statement like math dot square root of 4. Or you could use it like from math import sqrt and then just specify this, it should work. Now let's say, we'll just cut it short, import the math module, right? Now when I say import math module, this will not work. Okay, square root, this shouldn't work. See, it doesn't work. That's because I've imported the entire math module, right? So which means I have to specify its qualified name. So how about math dot square root, and then I write 4 here, I'll get the answer as 2, right? So I hope you are pretty much clear with how to make use of the import module or using the from keyword, right? So now let's say you would like to check the help of math module, right? So if you run this, squeeze 299 and double click on this, you will be able to see all the dot strings, all the functions, the trigonometric functions. Okay, so all the mathematical functions one by one, right? So it's something similar to one which I mentioned, right? So likewise, I have some constant values in my module. They will also have some constant values in their modules, like E, INF, not a number, not the value of pi, right? So I hope you're able to compare between the two. Okay, now let's say, but there are certain exceptions. Now let's say I would like to import this particular module. Okay, I want to import my module. Let's do this again. Import and then okay, or perhaps I just import the phrasing underscore C. All right, from a temp conversion, this is the name of the module, and then import phrasing, let's say F. Okay, I import this, and then I want to print the value of phrasing underscore F. Okay, I get the answer as 32, right? So what I've done is I've imported the module of the temp conversion. So when you import the module, a namespace will be created. Okay, a namespace will be created. So within this particular namespace, you will have all the functions, all the constant, all the variables, all the class and the object. And then when you import another function, okay, another namespace will be created. Now this is important. There could be two similar function names, one in this module or namespace, or another one in this namespace. For example, you have Tencent in 12D and you have Tencent in 12S. Okay, so if I want to call upon Tencent of 12D, I need to specify the name of the module or the name of the class, 12d.Tencent, 12s.Tencent. Okay, But at times what happens is, if you import just the constant values, now this is the disadvantage, right? At times, let's say you have freezing underscore f. Now here, the problem here is I don't have any namespace. I don't have any namespace for the temp conversion module. The reason is I've just imported just one constant value from the module. So which means I'm using the default namespace or the current namespace. Okay, so just a while back I've imported map module. Okay, so I'll have a separate namespace for the map module. But for this, there is no namespace as such. The freezing underscore f constant value is imported in a default or a common namespace. Okay, so this is something which you need to understand with regard to the namespace. And then coming back, now let's say I have my default value, or I have my own freezing underscore f variable. I come up with freezing underscore f equal, let's say 100, right? I press enter. Now the thing here is when I print freezing. Now there are two freezing, right? One imported from the temp conversion module, and one is the thing that I have come up with. Now let's say I want to print freezing underscore f. Okay. Now when I have this, what happens? I get to see 100, not 32. Okay. So what Python does is it will hide the imported one with the new one, with the new variable that I've just created, right? So you cannot have two similar constant names in the same space, right? So how does Python takes care of this problem is, the user defined or the one which we have created, right now will always hide the one which is imported from the other module, right? So this is something which you need to know, right? So I hope you're clear with this. It's not complicated as such. When you import a certain constant values, say the freezing from the module, when I print it, I get to see 32, and then I come up with another value, right? Another value, and then when I try to print that new freezing underscore f, it doesn't show 32 because the new one will always replace the one imported from the module, right? So I hope you are clear with this. So this is important. The namespace. The namespace is a group of logical related objects. Like I said, once the module has been created, once you import it in the program, the Python interpreter will create groupings. One grouping or a namespace for the math module, another one for another module. So likewise, it will go on and on. Okay. Now the next step is the processing of import module and from module. Now this is